Hi guys, Chia from ProDrones. So today we're going to look at the latest mapping sensor for the M400 platform. Previously we would have only the DJI L2, which is the LiDAR sensor, and the DJI P1, which is a camera full frame for photogrammetric mapping. The latest is the DJI L3. We're going to have a side-by-side comparison with how it's different from the L2, and then I'll show you how it's actually better by analyzing the data on the computer, and then we can then show you the differences in the data sets. So this is the L2, and now we have the L3 side by side. So the first big difference you can see is the massive difference in size. Of course, with the increase in size, there's an increase in weight. So it brings us to the first part of the system. This is a standard gimbal mount that comes with the M400. So as you can see, it's just a standard gimbal mount, right? Whereas the M400 comes with a slightly different gimbal mount. First of all, the supports are beefier, and it also includes a special hook to hold the L3. So if I were to place the L3 into position without locking, as you can see, it's still unlocked. It's already supporting its own weight. So there's an extra clamp here so that in the case when you remove, it doesn't drop to the ground straight away. Now this gimbal mount will only work with the L3 and no other payload. So if you intend to use the drone for multi-purpose use case, where you will switch payloads, that is one thing to take note. So you may have to carry this original gimbal mount with you, as well as with the tools to swap them out all the time. In the event you install anything other than an L3 onto this gimbal mount, for example, when we installed the H30, it would beep for a while, and then after that it would just shut down. There was no damage to the camera whatsoever.
Hi guys, Sean from ProDrones Asia here. So today we are in the park where we actually have flown the L1, L2 Mavic 3 Enterprise, as well as Matrice 4 previously in this park. So today we have the L3 with us to actually do the same flight plan again. So we actually can have a side-by-side comparison of actual data and how does the L3 perform in a real life scenario where we have buildings, we have thick vegetation. So let's get on to it. So we're done flying for today. So we actually have flown 3 flights, which is the non-repetitive, linear, and the new star-shaped mode that is actually included in the Zenmuse L3. We're going to go back to the office right now to actually let Wen review all the data and actually have a conclusion of should you really buy the L3 or not.
Okay, so we're back in the office, and what we're going to do is we're going to look at the data. Now, I have some old data from the L1 and the L2 as well, And we're going to compare it against the L3 data and various flight modes of the L3. So we're going to do this first simple thing, and is to look at the linear to linear flight data. So this is from the L1, right? And let's do the simplest thing, and we take a look at the area underneath the trees. So I'm just going to do a quick cross section from here to here. So first you can see that when the vegetation is sparse, it actually does get pretty good ground level data. There are some holes. Maybe we go with something a little heavier. Let's take this part here. So you can see the vegetation here is a lot thicker, and what you're seeing is a lack of points on the ground. Right? We're going to change the classification to elevation. Maybe that helps a little bit. All right. When we compare this with the L2, so the first thing you see is that the L2 has a lot more data. The ground is a much more complete line. So let's take L1. All right, so you see in L1, there's a gap here. Maybe we change the intensity. Right. So you can see there's a gap here, there's a gap here, there's a gap here, there's a gap here, there's a gap here. Whereas when we compare with the L2, it's more or less an almost contiguous line. If we take the L3, so it is a perfect line. You're getting every single piece of data underneath it of the ground. Yeah, so this first of all indicates two things. One, the laser is stable enough, strong enough. So this gives us an idea of how good the system is. The laser has enough penetration, is fine enough and has enough penetration power for us to get the ground, to the point that we can actually start to recognize things. For example, we actually see that's a car. So it's a fully shaped car underneath the canopy. I think the same can be said here. Right? We're not just getting the trees, we're also getting the tree trunks. Right? You can see here, it's not just the trees, but the vertical trunk. So this laser not just holds true to its multi-return, but it also has enough spread and intensity to actually get the trunk of a tree. And that is a truly impressive metric for a LiDAR system. So how this helps is, let's say if you are doing forestry scanning and you need to work out the biomass, so you can actually separate trees individually by using the trunk, right? Not just the canopy, because certain tree species have very wide canopies. So how this helps is that if you're doing things like forest inventory, you can actually isolate tree by tree much easily. Now we look at the return number on the ground. It varies. So it means we are getting a lot of points, not just the first points, the strong signals from the LiDAR, but also the ones that have gotten past the canopy. So basically, when you have a LiDAR, first you see most of the blue and red is at the top, so which means it has hit the canopy first, right? The top of the canopy, and then you get your yellows, your greens, right, and the oranges, and those are the further returns. And if you look at the ground level data, you can see there is actually a healthy amount of blue, red, which are the first or second returns. And this is a good sign, meaning that the laser's penetration is really so strong that the strongest return you can get is from the ground, right? And this is directly from underneath a tree. Now, usually what this translates into is a much better elevation model. So let's take a simple slice of road and we can see it for ourselves. Another very common way of measuring the performance of a LiDAR is to actually take a relatively flat surface and then we see how sharp the lines are. So what this gives us is actually the accuracy of the system, whereby an accurate system would have the points clustered very tightly. So this is from the L1. Now you can see the roof is roughly about, let's see, in this case, if we measure vertically, it's about 4 millimeters, 4.4 millimeters, right? Now let's see the same data from the L2. First of all, immediately you can see it's a much tighter cluster. This is also roughly about 4 millimeters, but you can see the spread of the data is a lot smaller. So to illustrate the point, this is the L2's cut, this is the L1's cut. So you can see the spread of the data is a lot more on the L1. Okay, this is the L2. You can see it's a much tighter roof point. Now let's take a look on the L3. You can see it's a very, very, very fine line. It measures, it's a very small amount. Let's see if we can zoom in, try to get this. So it's less than 1 millimeter of distribution. If we take a worst case, something like this, roughly it's about 2 millimeters. So it's half the distribution of points across for the same flat surface. So this gives a very, when we talk about measurements, you know, the 4 quadrants where something is accurate and precise. This is a very good example of accurate and precise. Again, we're going to do this with just a small stretch of road. Now, as you can see, the road is thin. It has a very razor thin spread of data. I've had to zoom in quite a lot. So just taking a random point like this, the distribution is small. It's about less than a millimeter. It's well below 1 millimeter. Okay. And if we take the same spot for the L2, you can see the spread is actually quite large. Now, just for reference, this is the L2, this is the L3. You see, it's in orders of magnitude. So this one roughly would be 14 centimeters, and this would be less than a millimeter. So we are talking about very much greater accuracy, tighter tolerances with your measurements. So this is really survey grade data we're looking at here. Of course, just to entertain ourselves, this is what it looks like on the L1. So this is the L3 versus the L1, and this is the L2 versus the L1. let me try to change the, yeah. So you can see the distribution of the data. Okay, so the yellow line is from the L3, the red dots are from the L2, and the blue dots are from the L1. So the first thing you're gonna see is this massive jump in your precision, your accuracy, right? So the consistency of the data is going to be very high. Of course, it all falls back to how we control our references. Okay. Now another interesting improvement is actually in the ability of the sensor to colorize data. So let me zoom out a little so that you can see this a little clearer. Okay, so notice that the squares here, the white squares on the ground, it looks like there are two overlapping squares. So in reality, actually, there are just one big square. So you can see the colorization is a lot more accurate here. And if we take with the latest L3 data, sorry, and if we compare with the latest L3 data, the difference is even more marked. Now, although the data is colorized much more accurately, I still do not recommend performing alignment using RGB. The best method is still to go by the intensity, because you're getting pure LiDAR returns. So let me find one just to show you. Now this is a good example of why intensity is actually a very good reference for alignment. So if you can see, as it is right now, the squares here in this small space are actually very well defined, because these are the actual returns from the LiDAR. You can see it's either yes or no, you know, and we can actually widen the distribution of the colors. So you can see here the squares are very well defined, right? We can actually trace the outer line of the square. Same will probably be for the L1, which is problematic because its intensity return is actually not as good as the other newer ones. And it doesn't really matter mode you're using. Of course, linear gives the best output for cases like this, but you can already see the squares being marked around here. We also took the effort of measuring the output accuracy. So we have placed control points, checkpoints all over the site. For example, we have one here, right? As well as several others all over the site. So, and we've actually counter-checked the accuracy of the measurement. XY is no more than 5 centimeters. Z was around the same as well. So we're looking at a pretty precise system out of the box. And that is with unreferenced data, meaning we did not align the XY during processing to fit the other data points. This was without fitting. As it was free floating, we already had the data no more than 5 centimeters off in the X and Y dimension. Yeah, so I guess that gives us a pretty good idea on the accuracy of the system. Let's recap a few advantages of the system over the L1 and L2. First of all, you have the much higher resolution RGB cameras. Second, you have much more 16 returns as well as a finer laser, and of course the high-speed scanning modes. So what this gives you is actually more precise and much more detailed data. On top of that, a big difference during operation is reduced need for warming up the sensor and calibration. We can calibrate before or after, and the data will still be relatively fine. And as well as the intensity of the data is scaled so much better compared to the L2 that we can actually use the intensity reading for calibration work in so much more easily when we compare with the L1 or L2. Of course, the precision as well as the accuracy of the sensor is so much more improved, as we saw with the cross-section cuts, right? So that makes it a very good survey tool for large swath work. So I hope this video gives you a better idea of what the L3 is. Just to remind you, the L3 only works on the M400 platform and no other platform as of this moment. If you have any questions, you can put them in the comments below or email us. And as always, thank you and fly safe.